All right, let's get right into it. Today, we're pulling apart one of the wildest vulnerabilities I've seen in a long time, CVE 2026-24061. The name says it all, root for free. So get this, for 11 years, 11, a critical vulnerability was just sitting there, hiding in plain sight. It was buried in a piece of networking software that, honestly, most of us probably thought was ancient history. And when I say critical, I mean it. On the CVSS scale, which is how we score how bad these things are, it gets a 9.8 out of 10. That's not just high priority. That's a drop everything you're doing right now kind of problem. It really doesn't get much worse than this. So what does a 9.8 get you? Well, it gets an attacker instant, unauthenticated root access. We're not talking about a complicated exploit chain here. There are no hoops to jump through. It is a straight shot, a wide open door to complete control of a system. Okay, so let's properly introduce this thing. We're talking about a critical authentication bypass vulnerability in GNU's version of the Telnet daemon. You know, that old school tool for logging into servers remotely. This isn't just a bug, it's like a ghost from the 90s came back to haunt our modern networks. And you know, the security community's reaction really says it all. Safe Breach Labs nailed it when they said this bug looks like it was taken right out of the 90s. And that's the crazy part. The fact that this survived for over a decade is just shocking. It's the kind of thing that sticks around because everyone just assumes it's old, stable, forgotten code. So how on earth does something like this actually work? Let's pop the hood and really dissect the root cause of what is a remarkably and almost comically simple flaw. At its core, this whole thing is a classic case of what we call argument injection. So here's an analogy. Imagine a login screen where instead of typing your username, you could just type -let me in as admin, and the system just does it. That is pretty much exactly what's happening here. The system gets tricked into treating part of a username as a command. And this timeline? Wow. It shows you just how fast a forgotten bug can turn into an absolute wildfire. So it's introduced way back in 2015, sits there completely dormant for over a decade. Then, the moment it's disclosed, it takes the folks at Grey Noise less than 24 hours to see it being actively used by attackers in the wild. And just 2 days after that, a full working exploit is on GitHub for anyone to download. Now, the attack itself is just beautifully simple. You connect to the Telnet service, you tell it, hey, I want to send some environment variables. Then you send a specially crafted username. The service doesn't check it, doesn't sanitize it, it just hands it straight to the login program. And that's it. Game over. You're in. And this, right here, this is it. This is the entire key to the kingdom. A single environment variable, user, gets set to -f root. That -f flag tells the login program, hey, don't bother asking for a password, and root tells it which user to become. It's just that simple. Okay, theory is one thing, but let's see what this actually looks like from behind the attacker's keyboard. Let's put this into action. An attacker just grabs that public proof of concept script, points it at a vulnerable IP address, and hits enter. That's it. One command. This script does all the heavy lifting, handles the whole negotiation process automatically, and you can see it right there in the output, just confirming, yep, payload sent successfully. And boom, just like that, the attacker gets a shell prompt. No password, no login screen, nothing. So what's the first thing you do when you get a shell? You run who am I to see who you are. And there it is. The system replies, root. They have complete, total control of the machine. The attacker now owns this box, plain and simple. So the big question is, how bad is this really? I mean, who is still using Telnet in this day and age, right? Well, let's try to measure the blast radius. According to Shodan, which is like a search engine for every device on the internet, there are over 200,000 devices out there right now publicly advertising that they're running a Telnet server. And if you look at data from Census, another internet scanner, the picture gets even bigger. They see over 1 million devices listening on port 23, which is the default for Telnet. Now, to be fair, not all of these are going to be the vulnerable version, but it shows you the potential scale we're dealing with. And this is really why it matters so much. Telnet is still alive and kicking in these critical and often very hard to patch places. We're talking industrial control systems, embedded IoT devices, old network gear, legacy servers, the kinds of systems you can't just reboot or update whenever you want. That's what makes this bug so dangerous. And if you look at the data from Grey Noise on what attackers are actually doing, They are not messing around. Over 83% of the time, they are using this exploit to go straight for the root account. They aren't trying to be subtle. They want total system compromise from the very first move. Okay, enough doom and gloom. Let's talk about solutions. How do you shut the door on this ghost and make sure it stays gone for good? Okay, your immediate action plan should be pretty straightforward. First, if you don't need Telnet, just kill the service, turn it off. Second, firewall port 23. Don't let anyone from the outside talk to it. Third, get these systems off the public internet if they're on there. And finally, if you absolutely must keep it running, you need to patch to the latest version of GNU INET utils immediately. But really, patching is just a temporary fix. The real long-term solution here is migration. It's time to finally say goodbye to Telnet. I mean, look at the comparison. It's insecure, it's unencrypted, it sends your password in plain text over the network. SSH is the modern standard for a reason. It's secure, it's encrypted, it was built for the world we live in now. It is long, long past time to make the switch. You know, this whole thing is such a powerful reminder. A simple, absolutely devastating bug from 2015 went completely unnoticed until 2026. And it really leaves us with a pretty critical question we all need to ask ourselves. What other ghosts just like this one are hiding in your own legacy code?